But an ultrasonic transducer, which is what generates the ultrasonic cleaning activity, can be incorporated into other equipment, including sinks with dedicated ultrasonic bays, into washer disinfectors with ultrasonic cleaning chambers. So it's not just about freestanding sonics. There is other technology and ways to get that ultrasonic energy to clean instrumentation.
Rising above the ultrasonic cleaners and the clanking of stainless steel are the ideas and voices that are changing an industry. You're listening to the Beyond Clean podcast, the central nexus for people, processes and products that are improving our sterile processing world. Each week we speak with frontline technicians, CEOs, engineers and entrepreneurs with a common goal to help you fight dirty, every instrument, every time. Whether you're tuning in for education or inspiration, we're glad you did. Now turn on those washers and turn up the volume. It's time to go Beyond Clean.
This week, we speak with Karen Owens, the Senior Director for Clinical and Customer Education, and Sarah Brown, the Senior Product Manager at Sterile. And we're talking about ultrasonic cleaning technology. Really excited to get into the studio with these two ladies to dive in to all the intricacies, all of the workflow, all the best practices around this key piece of equipment that sometimes can kind of get forgotten about in the corner. Or if you're not forgetting about it, sometimes it can be misused or underused. We really want to drill down to the core of the beautiful buzz that breaks down bioburden. So hang with us here. We'll be right back with Karen Owens and Sarah Brown.
I'm Justin Poulin.
And I'm Hank Balch.
From 17 studios, you're listening to Beyond Clean, the global voice of sterile processing.
All right, so we're here in studio for another great episode of Season 17 of Power to Process, talking about all the equipment in sterile processing that keeps our departments going. And of course, this episode, we're talking ultrasonics, the beautiful buzz that breaks down bioburden. We got some terrific guests in studio with us today, Karen Owens and Sarah Brown. Welcome to the show, ladies.
Thank you.
Thank you.
Happy to be here.
And now, I know, Sarah, you're not a new name or face to the Beyond Clean podcast world. Folks have probably heard from you before on a previous Sterile vendor spotlight. But can you introduce yourself just briefly, maybe for folks who are tuning in for the first time?
Sure. My name is Sarah Brown, and I am the Senior Product Manager at Sterile. And I work with a lot of the technology in the decontamination area. So everything from the sinks and ultrasonic cleaners to the washer disinfectors and cart washers.
Awesome. Thank you. And Karen, you haven't been on the show with us before, but we've talked about you quite a number of different times just because of the impact that you've had on a lot of us actually who have worked at Beyond Clean, including myself. You are the one who hired me off the street back in 2009 in Louisville, Kentucky. And you hired me again as a manager and you recommended me as a director. So we go way back into the glory days of sterile processing. Plus, you also hired and mentored Michael Matthews, who helped us launch the show. So a lot of impact to Beyond Clean, but it's a pleasure to finally get you on the show for this fun interview.
I'm really happy to be here. And I do have Hank stories, if anyone wants to know.
You do. Yeah, stay tuned for bonus content for all the Hank stories from Karen. But Karen, can you tell us a little bit about yourself too? I know you're the Senior Director for Clinical and Customer Education at Sterile, but for those out there who don't know the rest of your background, just give us a brief little bio.
Oh, gosh. So I'm a nurse by training, worked in the OR for many years, was a manager and director in sterile processing, and I've been with Sterile for the past 7.5 years, I guess. So yeah, lots of experience, done lots of great things and worked with a lot of great people. So happy to be here.
And you've won some awards, the Healthcare Purchasing Department of the Year Award. I know you're an Isham Fellow, or I guess HSPA Fellow now.
Yes.
So yeah, a lot of great accolades, a lot of good experience there. So let's get to the topic at hand for this episode, ultrasonics. The vast majority of folks tuning in have an ultrasonic in their department, most likely. If you don't, and you need one, I hope by the end of this episode, we're going to give you enough information to go back to your manager, to your director, to your perioperative manager and say, hey, like, I know we've been getting by maybe without one, but we have got to get one of these babies. If you have one already, I hope by the end of this episode, you'll get introduced to some of the key concepts around how these machines work and how to keep them working properly. And again, walk away with a little more confidence in stepping into decontamination tomorrow to use this equipment correctly. Let's start with you, Sarah. Can you give us a little history on ultrasonic technology itself in healthcare broadly, and then in particular, the applications that we have here in sterile processing?
Sure. Ultrasonic cleaning, the origins actually started in the 1950s. It expanded from laboratory use to broader applications when Bendix Corporation brought ultrasonic cleaning to its production line in 1952. The company experimented with ultrasonic technology to find an optimal method for tank cleaning. They learned that ultrasonic cleaning, in particular, was highly effective at removing soil and surface contamination. Today, ultrasonic cleaning is used in multiple applications, including sterile processing. From circuit boards and electronics to automotive parts, many things are cleaned using ultrasonic energy.
I love that you bring up that automotive piece because I've been watching some TikToks, I admit, and I've seen some cool ultrasonic cleaning of like engine parts and stuff. And I'm like, hey, I recognize what's going on there. So yeah, that's absolutely true. In the application of the technology itself, this ultrasonic energy that Sarah mentioned, Karen, how does this work out in sterile processing? So I'm thinking like in the sinks, the cleaners, the washer disinfectors, like where do we see this energy show up in a normal department and equipment?
Well, ultrasonic cleaning is used for obviously different types of instrumentation in a sterile processing department, right? Most people are very familiar with freestanding sonics in sterile processing, but an ultrasonic transducer, which is what generates the ultrasonic cleaning activity, can be incorporated into other equipment, including sinks with dedicated ultrasonic bays, into washer disinfectors with ultrasonic cleaning chambers. So it's not just about freestanding sonics. There is other technology and ways to get that ultrasonic energy to clean instrumentation. Some types of equipment provide ultrasonic cleaning really primarily on the surfaces of medical devices. And then there are some also that provide sonic irrigation inside the lumen of a device or flushing during sonication. And it's really essential to have a full and complete understanding of all the instruments that are being reprocessed to determine what kind of ultrasonic cleaner is needed for a department's decontamination workflow and processes. You really have to know what you have and what is required and what the IFU states.
Yeah, Karen, I'm so glad you brought up that IFU piece. We'll actually touch on that a little bit later here, but understanding the equipment that's available and the complexity of the equipment, as you mentioned, it's not all those standalone ultrasonics that we're all most used to. It is getting more and more complicated and complex out there, which means more solutions, but it also makes it harder for that decision making in the moment for technicians in properly routing instrumentation to the proper equipment and ultrasonic that needs to be used for that particular piece and tray. But before we go into more of the IFU part of this conversation, I do want to go back to Sarah here for a moment and talk about how chemicals and water interact with this ultrasonic energy that we're talking about. Like, can you outline maybe some of the basics there, Sarah, for how this all works for those of us who are not too keen on the scientific side of things?
Sure, Hank. I can go over some of the basics. It starts really with cleaning. We all know that cleaning is one of the most important steps in reprocessing a medical device. Ultrasonic cleaning is particularly useful for hard-to-reach areas on a device. This includes things like fine serrations or box lock joints. It can be used to dislodge and flush soils from intricate channels using sonic irrigation, and it's also gentle on delicate instruments like MIS instruments or ophthalmology devices. The ultrasonic cleaning process uses mechanical vibrations to agitate a solution to aid in the removal of soil from surfaces and, in some cases, inside lumens. The sound waves in the liquid produce microscopic implosions of bubbles that collapse on contact with surfaces. It creates almost like a vacuum-like scrubbing action that removes that soil from surfaces. This effect is called cavitation. The cavitation then removes bioburden from the surface of the items submerged in the chamber. You mentioned chemistries in addition to the ultrasonic energy. The chemistry piece is important as well because it's important to use a chemistry that works well with the cavitation inside the ultrasonic tank. And most instrument reprocessing instructions, or IFUs, require the use of an enzymatic cleaner. So it's really important to select an enzymatic cleaner that works well with the cavitation inside the ultrasonic tank. Specifically, there are some chemistries that have a lower foam profile that work well in that highly agitated solution. So it's important to think about not just the ultrasonic activity, but also the chemistry that gets selected with it.
Is there anything that we need to consider, Sarah, for the water that's used in these devices? I understand that chemical piece of the equation, but I'm assuming, too, that if any old chemical won't do, that any old water is probably not going to do as well. Is that a correct assumption?
It is a correct assumption. I mean, there's two things to consider here. So the equipment and the chemistry will often specify some specific qualities of the water that's used with them. So, at Steris, we also formulate chemistries. So the labels of the chemistries that we formulate will specify a range of water quality. The equipment itself will also specify a range. But another important consideration, and Karen and you both touched upon this, are those IFUs, because the instrument IFUs will often call for a specific water quality to be used as well. So it's important to really factor in the equipment, the chemistry, as well as the devices being reprocessed with what the water specifications.
Yeah, that's great, Sarah. And I'm assuming that with ST108 coming down the pipeline, to pardon the pun, that there's going to be a lot more emphasis and conversation around that water quality piece. So that's an important consideration there, across the board. And so, Karen, I want to throw over kind of the magic question to you. This is one that's very, very practical. Everybody's asking it, from the new technician kind of even up to the department manager and how they're building policies and workflows. But the question is ultrasonic cleaning required? And if so, what are the exceptions? And how is this reflected in the manufacturer IFUs that we're seeing today?
So actually, in my mind, that's kind of a really simple question. As most people know, ultrasonic cleaning is appearing now in more and more and more manufacturers' IFUs. It's required now for most orthopedic and neuro instrumentation, as well as other complex devices. It's not typically required for more basic instrumentation, but it's always best to refer to the manufacturer's IFU for the instrumentation at your particular facility and, to confirm what's required for your devices. And the reason I say it's kind of a simple question is because really the bottom line is if the IFU for the device that you're reprocessing requires ultrasonic cleaning, then you should have one in the department and you should be using it. IFUs are not optional.
I'm assuming then if we've got folks tuning in who don't have any kind of ultrasonic energy in their decontamination area, the first step they need to do before putting one on the capital request is to locate an IFU or two or three, then take that up to the C-suite. Would that be a good strategy, you think, Karen?
Absolutely. Absolutely. If it's required in the IFU, then it's required. So
I know one of the projects that really sticks out in my mind on this topic actually was in one of the departments that we worked in together. It was led by our instrument coordinator at that time, John Rowe. And what John had done is create kind of a matrix of the critical items that we knew needed to be ultrasonic according to those IFUs you mentioned. Because the challenge is, in the office, on the clean side, we can review IFUs. We know the instruments that are supposed to go and not go. But when you're in decontamination, in your full PPE and processing through that manual cleaning stage, that's when you need to know, can this go in? Should it go in? Can it not go in? And one of the things that John did is kind of create this 1-2-page matrix that listed, 20, 30 of the most critical items that either could and should or cannot and should not go into the ultrasonic. That way it was an easy reference. Actually put it on the wall there in Decontam. And I know it was really helpful. And there's probably, with the increased presence of these technologies and tracking systems out there today, there's probably even better ways now to hardwire that step in that cleaning workflow and actually be scanning into your ultrasonic cleaner and potentially building in hard stops if this device is not supposed to go in. I'm sure there's going to be audience members that have done that, but that's really that piece in tying the IFUs out there in the world into the practical step in Decontam to make sure that we're hitting that every time that we should in that stage. So that's a great point there, Karen. Let's talk about loading and unloading. And I'm going to throw this to you, Sarah. What are some best practices around that? What are some things that folks need to be considering or, potentially misconceptions out there around how they need to load and unload these type of equipment?
Yeah, absolutely. And Hank, it is a really important step because loading, in particular, any of the equipment has an impact on the cleaning outcome. Because if you don't load it correctly, of course, the cleaning action can't take place. So one of the things that's really important when it comes to ultrasonic cleaning and loading is to separate the trays. A lot of instructions for use ask for the tray to be separated because in a sonic in particular, that's important because those sound waves that we were talking about before, they clean the surface of an instrument that they first come in contact with. So if it hits a solid container, it's not going to reach the inside of that solid container to clean those instruments in the inside. It'll only reach the outside of the container. Another important thing to consider is to avoid stacking trays for a similar reason. Most ultrasonics have the transducers that supply that ultrasonic energy mounted to the bottom of the tank. If one tray is stacked on top of another, the ultrasonic sound waves can't reach the top tray. Some multi-level sonics on the market do have transducers mounted to the sides to make sure that ultrasonic cleaning action can reach multiple levels of instruments.
Yes, Sarah, a lot of great points there that you laid out, in particular with that casket or that rigid container piece, which, kind of brings to mind a good follow-up question, Karen, around all this energy is hitting stainless steel and it's actually being, created inside this stainless steel box, even if it's like in the sink setting or the washer disinfector. These things are typically loud, and sometimes depending on the equipment that you're using, it can really be loud. Is there any concern out there in the industry or from manufacturers around the potential for noise pollution in the decontamination space because of this kind of equipment?
Absolutely. I mean, if you remember, I think we often wore earplugs in decon because, with the sinks going, the washers going, the cart wash going, all these things, it can get very loud. And many types of equipment in decontam have obviously have varying noise levels. Something people don't think about or don't really know is that the chemistries that you use in sonics can also have an impact on the noise that's generated by the sonic. When there's more foam in the cleaning solution in the sonic tank, it can cause the recirculation pump to work harder, and that introduces more air into the process. This can make the equipment even noisier. It's important to understand the impact that foam can have on the noise level in the equipment. And that's, to Sarah's point earlier, selecting a chemistry that minimizes that foam can contribute to a less noisy decontamination area. So, yeah, it's a concern.
I would have never even considered the relationship between chemicals and noise. That's interesting. That needs to go on the label. Quieter decontam, use this chemical.
Right.
So as we wrap here, Karen, we love giving practical, next steps, for folks that are tuning into these shows. And I'm wondering, because you've been on both sides of this, right? You've been in the clinical setting, you've made these decisions, you've run these departments, and now also on the other side, you're educating around this type of equipment every single day. What kind of tips would you give or encouragement to sterile processing leaders to make the case for adding or upgrading their current ultrasonic technologies?
Yeah. Before I answer that question, I would like to make a comment on your earlier comments about following the IFUs and decontam.
Oh, yeah, sure.
Obviously, tracking systems have really come a long way, and it's great if you're in a department that has a tracking system. There's ways to integrate the IFU information, at the tray level into decontam, and, you can see things on the screen, and that's great. But, often when I'm in the field or speaking or whatever, I often hear from those smaller departments that yeah, those things are great, but we don't have that. So what about us, right? And I happened to be in a department that did not have a tracking system. And I observed a process that they had created that I thought was, very simple and straightforward, but it was really helpful to those frontline technicians in decontam because, like you said, obviously they're gowned up and garbed up in gloves and water and solution and blood and everything else, and they can't really, be flipping through books or going to a computer necessarily for every single tray that they're processing. So this particular facility had a color coding system. And much like you'll see a tag or a barcode on a tray to scan for an instrument tracking system, it was just a simple tag that was color coded. And they had a color coding system in their department, and each color meant a different thing. For example, if it was a green tag, that meant that it was just processed in the sink in their normal fashion, meaning, cold water rinse to get most of the gross bioburden off. And then soak, they had a minimum soak time in their enzymatic, brush flush, rinse, and then, automated washer. And so it was just what they called kind of their normal process. And then maybe if the tag was yellow, then it went through the normal sink process. And then it also required sonication. And maybe they had a red tag that meant it was hand wash only, and then I think they had a black tag that meant that it required above and beyond special, processing. And so for those, they had laminated sheets where there were certain steps that needed to be followed. So, just wanted to bring that up because not everyone, has the luxury of having an instrument tracking system. And so, don't give up. Network with others, listen to podcasts, education, all those things. And because, sometimes there are ways that you can, innovate and make it easier for the technicians on the front line to do the right thing. So
I love that. There's so much creativity out there, to your point. And you're right. That networking piece is so critical just to learn because you're not alone. You're not the only one having this problem. It's almost guaranteed. But you got to get creative about how you engage and ask. And oftentimes, to your point, the solutions come from within. It's the people closest to the problem. They're like, hey, boss, why don't we do this? Or why don't we change this way? And if you're open to those innovations, it can be really, really powerful. To close this, though, going back to the previous question, what would you give? What kind of advice would you give to help folks make the case for this type of equipment?
Yeah. So Sonics unfortunately can be a bottleneck. If you don't have enough sonics for the number of instruments that you need to process and that need to be processed in a sonic, this obviously can slow down your workflow and even back up your workflow in decontam. If this is the situation at your facility, I would recommend collecting data and build that case that supports your need for additional sonics. That's important. We have to look at the work we have to do and the equipment that's needed to do it. And if you have a bottleneck in your department, whether it be from a sink or sonic or washer or whatever it is, it's pretty easy to see. Go in there at a busy time of day and, you'll know where your bottlenecks are. So collect that data and really build your case to be able to present the need for additional capital equipment. And when you're thinking about upgrading, sonics have come a long way. So they do things that they didn't do before. It's important, to have that equipment that, can monitor key parameters such as temperature, time, the chemistry that you have, and along with the mechanical cleaning and the ultrasonic energy as well. Newer equipment monitors these parameters, whereas older equipment doesn't. Modern ultrasonics offer new technology, also such as thermal disinfection and, also being able to reprocess those difficult robotic and laparoscopic instrumentation. So know what new technology is out there and build your case with that as well.
It really is night and day, to your point, on how far and how fast this technology has come. If you've been used to using the same old sonic, for 5 or 10 years, you really be shocked once you look out on the market and say, oh my goodness, they can do all these things, wash all these things and have all these connections and accessories. It's pretty exciting to see in the industry. And I want to say one last thing on that bottleneck piece, just to make sure that folks hear us today. That piece and that backup that Karen mentioned is critical for making the case. But what happens, and I want to keep folks from giving into this temptation, is they have the bottleneck and then they start deciding, this is a bottleneck. Let's just skip this step. It's not that important. Let's just skip it. Let's keep the trays going. And so what happens is there is a bottleneck, but then there's a workaround that makes the bottleneck not look as big as it is. Well, what that does is that hurts your case for that piece of equipment because everyone's like, hey, you're getting everything through. I don't see the problem. And if there's not a problem, there's not going to be the investment. And I know that's hard because you don't want to feel the pain of the bottleneck and you want to get trays through, but you really got to balance that compliance piece, the safety piece, and then also just that efficiency flow piece until you make that case adequately enough to get what you need. Karen and Sarah, terrific job today. Thank y'all both so much for coming on the show to talk about ultrasonic cleaners and sharing your terrific insight with our Beyond Clean audience.
Thanks for having us.
Yeah, thanks for having us, Hank.
All right, and that was Karen Owens and Sarah Brown, and that's going to do it for this week's show. As a reminder, you can help support us by subscribing to Beyond Clean on iTunes, Stitcher, Google Play, and Spotify, or by downloading the most amazing smartphone application on planet Earth for iPhone and Android. That's the Beyond Clean mobile app, just in case you were wondering. We certainly appreciate a rating, 5-star, and a review, all positive, because your feedback is important to the show. If you have any topics that you would like for us to cover on a future episode of Beyond Clean, or if you yourself want to step on up to the virtual studio, please send us an email at info@beyondclean.net. On behalf of myself, thank you for listening to this week's episode of Beyond Clean.